So the whole idea is these tags can be used to track bags or containers. Yeah? But now if our containers are giving us viruses, that's a bit of a problem. Now this example comes from a dam in a northeastern state of the United States. So what they found was that a dam has got sluice gates, and when you raise the gates, water flows, and when you shut it, water is blocked. What they found was that these gates were behaving oddly. And ultimately they discovered that some Iranian hacker had gotten control of the entire control system of the dam, and he could at will flood that whole area or turn off the gates. So now just imagine, I assume Karnataka depends upon a certain number of dams. What if a dam is forced to overflow, right? How much damage that can do? And it's simply because that one computer system which was controlling the dam was exposed and got compromised. This example is showing you something dramatic that can happen. So all of you are used to this idea that, you can go to the web, you can get Google, you can go to all these sites, right? What happens if you can go to none of these sites? So here, this attack almost did that. It's called the Mirai attack. And the way the Mirai attack worked was it used something like 80 or 85,000 video cameras made by one Chinese manufacturer. Yeah? Now these video cameras are everywhere. Yeah? I don't know if in Mangalore you have video cameras on the outside of buildings. Is that true? Yeah. But in China there are, hundreds of millions of video cameras which are being used in the cities. Many in London, it's full of video cameras. Yeah? But a lot of these video cameras are not adequately secure. And this particular video camera had a username called username and a password called password. Yeah? And all of these video cameras are discoverable on the internet. So on the internet, I can log into these 85,000 video cameras. I can log in as username and password, and I can rewrite their firmware. Yeah? So somebody launched what is called a denial of service attack from these cameras. How many of you have heard the word denial of service attack? Okay, great. So maybe I should explain what denial of service means. I am a web server. Yeah, I'm a cloud server. You're all running applications. And whenever you do an operation comes to me. Yeah? I have been designed to handle 100,000 operations. Okay? Now, if one malicious user starts generating 1 million transactions for me, I am totally busy. I'm totally overworked. Right? I'm serving all these bogus requests, even though all your 100,000 requests are waiting. Yeah? So I cannot give you any useful service because I'm doing bogus work. And that is a denial of service. It's not like I'm dead. I'm working. I'm actually working very hard. I'm burning a lot of energy. But I'm not useful for you. My service to you effectively has been denied. So what they did was from these 85,000 cameras, they attacked one server on the internet which provides domain names. So when you say google.com, I have to look up what IP address google.com means. Yeah? I'm translating the domain www.google.com into that IP address. And that translation is called a domain name service. Yeah? Domain name service. So this server, DYN, was completely overwhelmed by all these fake requests from these 85,000 cameras. So it could not provide any service to people in Ohio, where I live, in Northeast Ohio, in much of Europe, and about a third of India. So there was a week last October where all of us had a dramatic slowdown of the internet where we couldn't access the domain name system. Yeah? And so we couldn't access Google, we couldn't access Amazon. A lot of services which were going through the DIN servers inside the internet were slowed down. And it took about 8 or 9 days for this particular attack to be controlled. Yeah? So try to understand the problem. This is a Chinese manufacturer. who is selling very cheap video cameras to many countries all over the world, and a simple username, password-based login is being used to reprogram these devices, and they are affecting the core of the internet. They are devices which are supposed to just produce local video are slowing down the entire internet. So continuing our list of stories, some of these are affecting medical devices. Okay? So several years ago, people showed in the lab that cardiac, like people have these pacemakers if they have heart issues. Yeah? So you could start, sending messages to these controllers that would cause them to lose their battery, to deplete their battery, or to do something wrong, like stimulate the heart, even when that was not necessary. Yeah? That's a very dangerous thing. To put in these pacemakers, you have to actually have surgery. And when the battery finishes, you have to be reoperated. And it's a terrible operation because it's not always successful. Yeah? So just imagine if an attacker who doesn't like you is going to deplete the battery of your relative's pacemaker. That is, where cybersecurity truly touches your heart. And in fact, this is not just an academic exercise. Last year, there was an insulin pump company which withdrew its product from the market because a very similar compromise had happened. They could take over and change the rate at which insulin was delivered. So you thought you were trying to reach a particular level, but in fact, you had reached another level. Okay? So the point in all of these examples is that over time, our attacks are becoming more sophisticated, okay, at larger scale, involving nation states, and having an impact which is both economically but also politically somewhat disruptive. So these attacks are sophisticated, like they're using the multiple zero-day attacks. They are persistent. Many companies are being attacked. Their enterprise things are being attacked at the rate of hundreds of thousands or millions of times every day. Yeah? They are multi-vectored. They're not using one weakness. They're using many weaknesses simultaneously. They are staged. They're not just one attack. It's like a baby attack followed by a distributed, different type of attack followed by a centralized, consolidated attack. They're multi-staged attacks, and they're increasingly harder to detect. There used to be a time when on our laptops we used virus checkers. Okay? Virus checkers were good enough to have a laundry list of known bad programs out there. And if you saw that pattern inside the virus checker being flagged, then you would say, I'm not going to run this program. Okay? As long as the new virus patterns were fed into my virus checker and I could do pattern checking fast enough, the virus problem was more or less contained. Today, the virus checker on your laptops is basically useless. In other words, you have to have it, and you're totally unprotected in spite of it. Okay? The rate at which viruses are changing is so high that virus checkers, in fact, are letting most corrupt programs go through. Right? So that is no longer how you can arrest this problem. And so you have to have different ways in which you detect that you are under an attack. And in fact, most of the attacks have gone into this category where, sorry, not most, a significant number have gone into a category where they are advanced. That you have a powerful adversary who is well-funded, who's got good VCs, and a good profit model who is behind this, and it's, therefore has to be competed with somebody who has equal sophistication. And this is a quote I keep just to sort of, be evocative. So there's a very famous computer scientist who made this prediction that the current US president will experience one episode where, because of cybersecurity attacks on things like things, people will lose their lives. So we've come pretty close to that, but it hasn't happened, and the expectation is we are entering into this one. So somewhat abstractly, before we start digging into some details of how these attacks are constructed and how you can deal with them, this is going to be a very hard space to protect. It's going to be hard because we haven't an asymmetric adversary. I have a very poor machine called an IoT device. Yeah? It's complicated because it's got many different forms. Yeah? And in addition to that, I've got an adversary who's constructing these well-funded, sophisticated attacks. And worse, even if I solve the IoT problem by constructing new devices which have got better hardware and software support, in spite of that, these legacy devices will remain. The Chinese company selling cheap videos will not necessarily die. There will be that product in some countries, if not in all countries, and other companies who will continue to build solutions where they forgot to do security, and they forgot to do it intentionally because they could not afford the cost of the engineering for security into their solution. So the legacy problem will remain with us for decades, and we have to, any security approach has to not only make your new devices secure, but also deal with the old devices. And as I mentioned to you, that there is a standardization problem, that we don't have standards for OS, we don't have standards for networks. Maybe we can standardize the application level communication protocols, but we cannot assume that one standard will work on all IoT devices and therefore the security problem will be solved with that standard. Yeah. Now the other thing to keep in mind that a lot of security is beyond technical details. It's about policies and laws and regulations and governmental strategies of how security is done. And that too is not easy in this space because these attacks are not within one country. These are not Indian attacks in India. Yeah? These are attacks in India from some other country. Yeah? So how do I deal across borders? That law is very well defined, is very poorly defined. And very often I don't have treaties with the countries. So how do I catch those people? How do we cooperate? How do we extradite people? All of that is unlikely to be solved somewhat quickly. And something that must be done is to try and make industry self-responsive to making solutions secure. So many of you said you play with Arduinos, right? And if you're playing with Arduinos, you're capable of making a cool new product. Yeah? And you make a cool new product, you use a 3D printer to box it up, you show how it can be connected to the cloud, and you're off to go, right? You can sell this thing commercially. It's not so hard to do it anymore. But if there isn't an incentive for you to make your solution secure, you are putting a device out there which will definitely get compromised. So how does the entire system incentivize you so that you start building in security from the beginning of your design is an important step. So let's assume that there are standard ways of making your system secure, but you still need an incentive for adopting them and paying that cost. And so that is a problem that must be solved. Then there is a huge vacuum in the law, constitutional law, right? Our law gives us, the freedom to live and freedom of speech, all of that, right? But what happens for data? Is my data mine? Yes? If I have a Fitbit and an attack happens for me, that happens on me or I'm involved in an attack, is that data on that Fitbit mine or not? The law is kind of murky on that. At least in the US, we've had constitutional cases where I could have said, do not use my data because it will incriminate me. But because of gaps in the Constitution, in fact, the data was used to incriminate. So that's a failure of law. Now, if you are a service provider, you are a cloud provider, and you have my data from my apps, okay, can the government actually take the data from you? It is my data. I let you use it in your service provider's solution. But if you still promise me that you will keep my data protected, right? Now, can you give it to the government and the government can prosecute me? And the answer is, again, at least in the US, the Constitution has a very clear way of allowing that to happen. So these laws will have to be changed in the US and in India. And like I was saying in the previous presentation, In fact, we don't have good models for how to create these laws. You know, our thinking about the law is based on what we have seen, say, in the Industrial Revolution. But this whole digital revolution creates a new way of thinking, which might need a new way in which these laws are created. So all of these are the non-technical aspects of what will have to be dealt with for cybersecurity. Yeah? Okay. So what should we do? Again, I'm at a very high level, and we'll start digging into details in a little while. So the first thinking is that, you know, when we build supercomputers and when we build traditional computers, we try to protect them in such a way that you could never break into them. Yeah? You know, we put in virus trackers, we put in intrusion detection systems, we put in authentication, so that the assumption was that only the legitimate party could use them. Okay? And that is what I refer to as the Maginot Line. The Maginot Line comes from the First World War story. The story of the First World War is after the Germans rolled over the French. The French vowed that they would never again be steamrolled by Germany. And the way they would do this would be that they would build a whole network of tunnels and supply chain by which they could have a complete fortress around the French border with Germany. And so they would have very powerful guns, they would have railroad tracks, they could supply ammunition at a very high rate. So they spent many billions of dollars setting up the Maginot Line. And when 1935 happened, the first thing that happened was that the Germans broke through the Maginot Line. Yeah? So what was believed to be impenetrable had small, subtle flaws in it, which, if exploited, you know, led to the compromise of that expensive solution. So this whole assumption that we are entering into a world where we will have not just billions, but trillions of IoT devices, and all of them will be secure, that's the wrong mental model. So we are coming from that bad world where all those negative things are happening, and yet we cannot plan for a world in which no negative thing will happen, because that's going to be impractical for many reasons. Yeah? So what we have to do is to recognize that many attacks exist, not just in software, not just in legacy hardware, but we can do attacks when we physically get in touch with the device. Or, in fact, even more interesting attacks, which I'll talk about, where just by looking at the energy being radiated from the device, I can figure out what keys are being used. Yeah. So we are at a point where we can do what is called emission security. Yeah. So my device, let me explain emission security. My device is receiving power from some source, from the wall power or from some battery. And this power is being distributed around the board. But anytime some computation happens, that computation changes the power consumption locally, and that creates some waves across the board. By observing those waves, which are radiated in electromagnetic form, I can figure out what computation might have happened. If I can figure out what computation might have happened, I can figure out what keys were being used. And now the key is being leaked simply because I'm confused. So the space of complex attacks, side channel attacks, is growing. And things like that, where I buy a bad chip, you know, for cost reasons I go to China and I order this, this Cortex M3 microcontroller from STM, but it's a fake Cortex M3. Yeah? Or it's not a fake, it works really well, but that hardware has got a hardware virus in it. Yeah? How do I check all that? So we're in a world where this is going to be hard to protect. So what we have to do is to change our thinking to say, let's make our devices as good as possible, but also design them so that when they get compromised, we know what to do. Can I turn off the device? Can I cut off the device, even if it's working, that the rest of the system doesn't hear it? Can I prevent this before this corruption spreads into the network? Yeah, how quickly can I do it, and how locally can I do this arresting becomes the interesting thing. So what we need to do is, in addition to building trustable IoT, we should build IoT which is self-verifying. That when it is running, it is asking itself the question, am I doing okay today? Am I the same person I was yesterday? is something in me unusual. So we're going to put in verification checkers at different levels of the system. And in addition, we'll have to put in some support for recovering it. If something has gone wrong, which I detect, or my parent in the base station detects, then they can tell me to reboot myself. Remember that secure boot I talked about earlier? As long as the secure boot isn't compromised and some channel that comes into me which says restart isn't compromised, I can recover a compromised device. So every device should be built not just with trust, but with self-verification and with recovery in it. Yeah? And what this means is that my control is now being shared. An IoT device is not an island unto itself. I don't only try to check my own integrity, but I also depend on my parent to check my integrity. My parent enterprise to check my integrity. And basically, it becomes a game. And that's the nature of security. So if there's one thing I want you to remember from this talk, security is not an absolute property. Security is sort of a qualitative thing. It's a state of mind. I feel secure because the realistic attacks against me have low probability. In other words, if I am richer than my neighbor, I'm well off. It's harder for the thief to compromise me than to compromise my neighbor. Or if I'm richer than my adversary, I am secure. Okay? So what we've got to do is to build systems which don't aspire to say there will be no compromises, but just that we are one step ahead of the adversary in dealing with them. Just one is enough. And that's the cat and mouse game. Every year, we get one step ahead, the adversaries become smarter, but then we have to keep getting smarter. So this is going to be an area where if you work in, and this is not the best thing to say, you will never be short for food. There will always be work in this area because of the nature of security. Yeah? There's always retraining going on in what tools you can use because the problem never goes away. Okay, so I've given you a slightly depressing story so far, yeah? That the problems are becoming very large, IoT has many forms, and we'll just have to be one step ahead. But at one level, keep in mind that sometimes IoT helps you design systems which are more secure. Okay? Remember, many of you were not there, but the examples I was giving was we are trying to catch poachers, criminals, yeah? People who are terrorists crossing borders by using IoT sensors. So I wanted to give you one example where IoT helps you actually for security. Now, one of the problems people have had is that attacks are happening inside facilities. Yeah? So this is a classic attack where somebody enters a building, he shows his card, he enters the building as himself. But then he uses somebody else's card to go inside a secure facility. Yeah? And then inside that secure facility, using the other credentials of the other person, he can access all the records and steal them or share them. Okay? So I don't know how many of you have heard of Snowden. You've heard about the Snowden attacks and the Snowden leaks. Yeah? So Snowden basically took on many identities, and he leaked a large number of classified documents from various agencies, specifically NSA. Okay? And that was a big setback for the NSA, because a lot of very secure techniques which the NSA used were made public domain. So now how could IoT help you with that? So when Snowden came into the facility, and at some point you discovered that somebody who has not yet entered the building has gone into a secure room, you could have discovered that there was a mismatch. So physical information actually can be used to secure the information. So even though IoT devices are humble, yeah, the kind of information they give can actually be used to make your computer systems, your data systems more secure. Yeah, so it's not all doom and gloom. You have to see that the good comes with the bad, and those applications are worth building.